Well, here we are. We got the Pieces team out here in Austin, Texas. We're on the University of Texas campus. Beautiful day today, but we are on day 2 wrapping up Civo. And yeah, I'm here, Tsavo Knott, co-founder and CEO at Pieces.app with our Chief AI Officer, Sam. Sam, if you want to say hi.
Yeah, it's been a great conference though, right?
It sure has. It sure has. I was saying kind of before this, talking to all the developers, enterprise developers, students here at the university and everything in between. It's been excellent to kind of not only reflect on the talk we gave, and we'll get into that a little bit here, but also thinking about where we've come, what we've built, and what we're building.
Absolutely.
Right? I think it's going to be pretty exciting. But yeah, I mean, let's do a little bit of a recap here on how the event went, how our talk went. It was the first time we've done a tech talk mixed with a product talk.
It was good
being
though.
on stage.
I enjoyed it.
Yeah, handed it off back and forth, which was awesome. But I mean, let me just kick off the framing real quick. And I know we spent a good bit of our presentation around what we built in phase 1, right? A place for people to put important resources that they kind of generate and interact with throughout their work in progress journey, right? Code snippets, screenshots, all the workflow context like links and files and projects and people, and saving that, right? So fundamentally a place for humans to save. But then also too, in the early days we said, can we do better? Right? Can we do better? And all the mundane tasks of having to organize and tag and title and label and do all of that enrichment process yourself, can we take that out of the picture when you simply paste a code snippet in, right? And so, we kind of broke down for the audience the technical components of that. And if you want to recap, some of the stuff that we learned and how it evolved, we kind of reduced that technical debt and made the experience better. That'd be great.
Yeah, absolutely. Well, first it was great just thinking back, right? And that's just thinking about stuff where we come. And I think at that stage, we were really focused on saving snippets. And so when you take a snippet out of the context that it comes from, you sort of lose a lot of the metadata.
That's right.
Like the related people, who sent it to you, these links, all the rest of it. And so, we were really focused on being able to generate that.
That's right.
So you grab the snippet, you put it into pieces, and then you kick off all these sort of
enrichment pipeline modules.
And one of the big challenges there was we were doing a lot of things, right? It's coming in, we were classifying it as text or code, we were telling the language, getting descriptions, titles, tags, all of this stuff that makes it easier to find these materials.
Right.
But one of the big challenges was those were quite different tasks at an AI level, right? And so we had, a separate model, each with separate architectures facing these features. Which was great, but
it's the naive approach, early days,
Exactly.
That's right.
But the real problem there was we had all of these different, we had CNNs, LSTMs, T5 for a bit, lots of the sort of embedding stuff, and the real issue was that to do that across 7 different tasks had a big sort of impact on the memory usage and the size of the app.
We have the hardware constraints of our consumer devices, right?
Exactly.
We got a lot of tickets that were like, why on earth is Pieces using 1.8 gigs of RAM? And we're like, well, we're early pioneers, shipping these small brains that are designed to title something, and tags it. But we got better at that.
So. Yeah, absolutely. I mean, I think the big sort of things we wanted to overcome there was because we had these separate architectures and separate models to retrain them, took a lot of time.
That's right.
Because we were doing it from scratch. And we also, there was a lot of overhead in data collection and data cleaning.
That's right.
So apart from these memory constraints, there were real sort of like experimental constraints around what we were doing. And so we were scouting around for a solution. And we found the T5, which was great, pre-trained on a lot of code. And we're just really fortunate that at that time, this paper came out. I think we found it about a month after it had been pre-published.
We were very early.
Yeah.
Very early.
It just solved a lot of our problems. So it's this method called LoRA. And basically what that did was it allowed us to deploy one model and then just train it for specific tasks by looking at a very specific layer in that model, the attention layers, and learning a sort of parameterization of that layer that forced the model to focus on aspects of the input that were particularly useful for each task.
Right.
And so what that meant was instead of having a separate model, separate architecture, or the rest of it for each of these functionalities, we could just deploy these tiny
bias modules.
Exactly.
Almost, right? Yeah.
Exactly. Slot those in. And that meant at inference, all we had to do was slot these in and out. I mean, it's easier said than done. Right. Slot those in and out.
I think that actually required an Onyx pull request.
It did.
I think it did.
It did. Brian was in
I think
there.
Brian he'd already done some work with Onyx, but I think he had to like PR that. So we were one of the first to like actually request in an Onyx runtime. Yeah. Can we dynamically slot, embedding layers? Right. I guess.
And they were really
modules.
They were really into it as well. The
blog
blog came out of that. All the rest. Yeah.
They were pumped.
Real start of how to ship Microsoft.
I know.
But yeah, no, that was amazing. And that let us deploy it easily.
Yep.
But it also solved a lot of our training issues, right? We then needed a lot less data to retrain these models.
That's right.
Instead of 100,000 samples, it was more like 5.
And also, I feel like the speed and the quality and the compute and memory requires. It's like speed and quality went up and compute and memory went down.
Yeah.
Right. Yeah. And I feel like we were able to. We also did some prompt work around some of that as well when we were doing the LoRA fine tuning and things like that. But all that said, that was kind of like phase one. It was like when you save something, make sure it's enriched, right? Like make sure the fundamentals are taken care of. There was one other nuance, which is like, even the embedding spaces that we have, can they expand to understand your things over time, right? Your links, your tags, your files, etc. So when you paste something similar, it's going to say, hey, similar item is related to a previous item that had this context. Is it so similar in the idea that we can assume this person is also related to that material, right? And so I think we really understood a lot about spherical versus graphical embeddings and making some really great architectural decisions there. But yeah, then we moved on to kind of phase two, being able to conversationally interact with your materials, both to understand them, but also generate net new things, right? In a multimodal regard.
Which brought in some huge technical challenges.
So let's talk about it, right? The GPT inflection. Right?
Yeah. I mean,
LLMs are real.
Exactly. Like the GPT came along and it, on the surface, in terms of quality of outputs, like it really solved a lot of our problems. Both, especially around the sort of data gen and LoRA models. But the problem with sort of using GPT directly for those tasks, I guess, is it's slow. It's not particularly good at coding.
Right.
There's sort of research out there suggests, you give GPT-4 a coding problem and bits of code it has to adjust, and in sort of 1.4% of cases, it was able to do this. The
issue to code base resolution.
Exactly. That's the one. And so we really wanted to do a couple of things there, right? We wanted first to bring some of that functionality local.
Yep.
And so that was really important to us. And
that, by the way, on that point, I think that's very important to a lot of people.
Yeah.
Right. I mean, we were going through the compliance process and we got SOC 2 this year, and the idea that you could do the entire demo, the generative components, the enrichment components, the integration, completely air gapped, offline. I think that really shocked a lot of people.
Yeah, it was a great moment at the talk, wasn't it?
Yeah, absolutely, right? Yeah, I mean, we didn't have good Wi-Fi out there at the talk we were giving, and I was like, don't worry, Wi-Fi off. Like you can see, share my screen, but that was certainly interesting, and I think it will continue to be interesting because there's a lot of like consumer education going on with what are they doing with my data? Are they retraining it for the next model? How secure is that? What is the privacy and permissioning and security around that data within an org, right? Can I accidentally have the large language model retrieve and augment and generate something that I'm not permissioned to access, right, within a large environment? So I think our approach so far, small, contained, expanding outwards incrementally is going to be healthy, given the consumer education that's level, right?
Absolutely. And you've got these, we've built from the start, basically, like being local has been really important to us. But these models are large, right? I mean, Mixtral, Neutrality, they're all big models.
Couple gigs of RAM, good GPUs, hopefully.
And then we were deploying them across 3 operating systems.
Mac OS,
obviously.
Someone knows,
like massive variety in terms of user hardware, like different GPUs, different CPUs. different environments, what have you. And so we were sort of really looking for a solution that would allow us to deploy these models in sort of memory efficient ways across all of that, without getting stuck in sort of developing separate runtimes for each possible combination.
Right. Dig into that a little bit more. I know you and the team worked really hard on a lot of that. Shout out Brian.
Shout out to Brian.
His head banging. But yeah, dig into that a little bit more. Yeah.
There were a lot of late nights. But yeah, basically we have been using Onyx and Onyx runtime, which worked really well for us, but for the smaller models. But for these bigger models, you really have to tap in to hardware-based optimizations, right?
Right.
And so we were looking at the market. We were particularly interested in TVM. And then I think maybe a week after it started looking, there was this big release from some of the people behind TVM, utilizing it specifically to make hardware optimization skills for these models. So we looked into the open source package called MLC, and that really solved a lot of our problems when it came to deploying these models and utilizing GPU. And so that was kind of our solution for deploying GPU. Excellent library, allows us to make hardware optimizations, compile a model, deploy it to the user.
Does MLC stand for ML compiler?
It does.
Okay, nice.
Machine learning compilation.
Yeah, okay, all right. ML compiler. I was like, that might be straightforward. I'm gonna. All right, cool.
And then at the time, you were really, really into Llama C++ as well.
Yeah. Right? There was one. Yep.
And that
Llama CPP.
Exactly. That turned out to be the best solution for running these models on CPU.
Yeah, that's right.
And so, we're now at the stage where we can deploy these local models super
very quick. I mean, we just released 5.2. We've got Gemma.
Yes,
Gemma. Right? You're telling me about this morning. Yeah, right.
And that's really exciting. And these libraries that we're using, they're so well supported. We can sort of utilize some of the contributions from open source, right, to get this super fast. So undoubtedly, give it 5 days. We'll be able to deploy Gemma.
Yeah, I would say the interesting thing, to also take a look at is like vendor lock-in. I think a lot of people are building systems that are uniquely leveraging one or the other. But, in our environment, we have developers in all different types of orgs, right? So, it may be the case that a tool powered by OpenAI cannot be leveraged inside of Google, right? Or a tool that is, powered by Google cannot be leveraged inside of Meta or, Microsoft, right? And so there are these kind of proxy wars that are going on. And we've really, really tried to play Switzerland by making sure that our orchestration, retrieval layers, the embedding spaces, all of that's in-house. But then we can very easily plug and play with a little bit of prompt work. And I know you can definitely touch on that. But plug and play large language models or smaller large language models, right? On-device ones. So tell me a little bit about, kind of completing and rounding out phase 2, some of the memory stuff, the vector database stuff, the prompt stuff, and maybe some challenges and things we've overcome regarding context windows, small and large, right?
Yeah. So I think let's dive into the prompts first.
Let's do it.
Right. A lot of, everyone's into prompt engineering right now. And one of the big issues there, I guess, is you've got these excellent prompts, but they're very keyed into specific models.
Right.
And so on our side, the engineering challenge was, how do we build a system which is isomorphic but optimized? So each of these prompts is built specifically
on a per model basis.
On a per model and per task.
That's right. You've
got like maybe 30 different tasks.
Yeah, a lot of prompts right now.
Yeah. And so that was huge. And as we were building that, we sort of started to see all these opportunities, right? Because once we've got that, we could start, because it's a really easy way to get context from the user and add that to a prompt. And I think one of the sort of pain points of releasing the systems, right, is you go into GPT, and to get a decent answer back, you actually have to do so much work.
You do. Yeah.
And you've got to find the little bits of information that are relevant to what you're asking. You need some examples, maybe. You need to give the language persona and the rest of it. And you end up spending, like 5 minutes
just on the back and forth and setting it.
And we're just perfectly positioned to solve that problem.
That's right. That's right. I think the grounding, just to talk about like what differentiated us in phase 2 and will continue to differentiate us is the horizontal nature of our product, right? It is exactly what you're talking about there, the right context, and also to like reducing the amount of work that a user has to do to get a nice high fidelity output, right? Yeah. I think that we do have this belief that conversational copilots, will be a default expectation, but they're even still a bit laborious to use, right? And so I think that, for us, some of the things that we're really, really focused on, and not to jump ahead too much, but is that horizontal context, right? What are you doing in the pillars of your workflow, the browser, the IDE, and collaborative environments? And so being at the OS level and understanding horizontally what's going on, what were you doing, maybe in the last hour, the last day, or in this scope of a project. I think that's really good automatic context. And then also just being able to play nice with other tools, right? So like as like GitHub or Microsoft, they go deep within their ecosystems, 365 Copilot, GitHub Copilot, whatever else. I think we want to continue to be that Switzerland player where you can imagine copilots will interact with each other in a very natural type of way. So, that's kind of the part 2 of the approaches. We're horizontal and we're Switzerland.
And like digging into what you're saying there about the horizontal, that's really sort of where our graph embeddings is, right? You've got different information sources in different modalities. You've got images, you've got video, you've got text, you've got code. How do you encode those in a way that makes sense?
Right. And how do they inform each other too?
Exactly.
Right? Because the different modalities are related. Just because they're different from a modality perspective doesn't mean they're different from an interpretation perspective, right? A screenshot of code is same as a text bit of code.
Absolutely. Right? And because we were generating a lot of stuff, we had lots of information about how these things are interrelated. Like this video comes with that code, this text, the rest of it.
We build those relationships.
Exactly. Yeah, we can infer those relationships and we can use them to say how these are associated. So the graph embed is really
that was a breakthrough. That was a breakthrough. And Dom specifically has really ran with a lot of that stuff. That was building on the stuff that, we figured out didn't work. Yeah. Right. There was a lot of work that I think Leo, yourself, and Kieran did to say, hey, process of elimination. Exactly. Right? We're trying to do something net new here. It's difficult. And I think like you gotta figure out what's not going to work as fast as possible, so you can focus on what's where we're going with some of the harder tech. Okay, speaking about where we're going, we kind of wrapped out with some really good stuff at the conference regarding kind of proactive saving, workflow shadowing, and the feed. We got a good couple of questions that definitely triggered some responses. So you want to touch on that a little bit?
Well, I know it's something you've been really driving for a long time, right? And
I would just add, it's not how we get it done. It's just the first principle of helpful tools, right? There's a lot of ways to make a tool helpful, but for us, we want tools that just feel magically helpful, right? Proactive. Like as a developer, I already have to know so much, learn so much, and do so much. I need a tool that doesn't make me learn, doesn't make me do, and knows what I need when I need it. Exactly. It's helpful, right? And I think like those are the types of systems that we have the opportunity to show the world are capable and possible. And I'm really excited about bringing the last like 8 months to a year of work and design and kind of product effort to the public in this upcoming quarter. Tell us how we're getting it done.
So I mean, going back to what we were saying about this, this pain here where you've got to assemble everything from everywhere, right? So we'd sort of solve that halfway, with using these retrieval algorithms we've got and these graph embeddings to sort of shove that data into your prompts. But then there's still the other half, right? It's like you've still got to remember to save these things.
That's right.
And I don't know about you, but that's not the way I work.
Maybe if you banged your head enough as an experienced developer, you're like, I know I should definitely take notes. But sometimes you're just moving too fast, and also too, it's just like a very like conscious muscle you have to develop is like, I'm going to need this later because one, I might need it for myself, but two, I might need to share it. Absolutely. Right. And I might need to explain my work and so, I mean,
I guess our solution there would, the solution was, let's get right into where you're working. Let's look at what you're doing. Let's take advantage of the fact that, we can look at your screen, have a look at what apps you're actively using, and screenshot those as you go, and then feed that information.
I think it is the relationships between the workflow pillars that we want to capture, whether it's through hardline plugins or vision processing. We want to understand what you're doing in these pillars and across those pillars that is related. And from the relatedness, right, what you're doing in the browser and what you're doing in the IDE and who you're talking to about that task in chat, like GChat, Slack, or Teams, that relatedness signals importance.
Absolutely.
And at a certain threshold of importance, you want to make sure that's captured, saved for you, served back to you, and eventually your team and your org later on, right? And that's really where we're at. The mechanism of capturing, that's actually quite easy to do. You can capture everything, but what you actually process, that's really where you guys are spending a lot of time right now.
Yeah, exactly. Like you can capture everything, but it's not really that useful, right? Because you don't know what's important.
That's right.
And so so it's all about like using the developer's activity or
patterns,
the patterns and the behavior between these different things to infer what's important. And it involves a lot of filtering. It involves, a lot of sort of detecting things to remove from that flow. But the use and the value add there is incredible.
Yeah, it's effectively it'll get to a point where you install pieces. Maybe 6, 7, 8 hours later, you're getting suggestions in the feed, right? You're looking at something, on a Webpack config, and the pieces feed right there has, hey, you should talk to Sam. Because you worked on Webpack last week. You should look at this project. You should look at these other related documentation links. You should look at this file or saved snippets that you have, just based on your current context and things that were proactively captured. Now you have kind of your next step, or your suggested next action auto-completed, right? And doing this in the browser, in the IDE, in the collaborative environments, that's the goal. And so the Jarvis, the Iron Man Jarvis for developers is where we're going to be going with it.
Yes. Actually. And then you've got the issue, like once you have this information, like how do you surface it?
Right.
This is where
in a low friction regard, right? Where they don't have to learn this button does this, or this is how I should ask this type of question, or this is just how I should manually set my context. Like even going, to your Copilot and saying, hey, use my context from the last 6 hours. It's a beautiful way to just not have to think about like what is the right folder or like let me add this link and all this. It's just like last 6 hours. Right. And that's just a great way to ground the Copilot. Where you go and you open it up and your feed is just like, everyone knows how to use a feed, right? It's like if it's there, you scroll it a little bit, maybe reuse it, you open it, you share it, do whatever else, or you refresh. Right. And by the way, the feed changes based on your context. You switch from tab A to tab B to tab C. That feed is getting proactively refreshed from the things it already has, but also the things that it's continuously capture. Right. And I think that's why it's going to feel very with you. And that's the super important thing is systems that feel with you inherently feel helpful. Right. And I think like that's where we're going to go with some of this. It certainly stirred some responses at the
people liked it a lot.
That's right.
And I mean, even, we're in stand up and we're thinking, wouldn't it be great? You hit topics and stand up and that's just surfaced in that feed, and it's just that's it.
It's going to be magical, and we need it, And I think like one of the things that we talked about overall, and I know we'll probably have to wrap it up here soon, but one of the things we talked about overall in the conference is that the role of the developer is changing, and I think that it is less about what you're doing in isolation, writing code, experimenting. Like you're of course going to have that, but I think it's more about connecting dots now. Right. And as it gets easier to write code in one languages or many languages, something like that, I think the developer will kind of lift up a bit out of the code layer and start to work on more projects, connecting more dots, more cross-functional teams. I think that's where things are going, right? Because the idea of writing code is actually going to become more of a commodity, with the advent of these large language models. So as you move into that world of context and more rapid context switching, I think that pieces will intersect it and complement it quite well with what it'll be doing. So
for sure.
Well, Sam, as always, it's been great to be out here, give our first joint tech talk together. It was an awesome conference, and shout out to Civo for making it happen, and
what
do a lot more of these. Yeah, great spot in Austin, great weather. I know I've already gotten like 2 shades darker, so we'll take that. Usually it's the blue light, but awesome. We'll wrap it. Cool.